Hello, Mario, and this is the second question from tutorial 5. This one has an electrical flavour to it. So Bob wants to stretch a power line or across the river from pylon B to pylon C. How much line does he need? So he's been able to determine a distance for like a baseline on the side of the river that he's on, 107.8 from A to B. And then at A, he maybe uses a theodolite or some sort of instrument to observe an angle of 28 degrees to C. Usually in these cases, he can afford to be a little bit, get a little bit more than he needs to be sure. But anyway, we can calculate this out. So let's go. First of all, we need to just consolidate our triangle. It's just been drawn up here, sketch format on a whiteboard. So let's sort of make it a little bit easier to understand. So we'll put in our lines there like so. Now we've got to label our lines. So this one here is the longest side opposite the right angle, and the right angle's B, so we'll call it little b, and it's the hypotenuse. Very good. Now the angle we're dealing with is this angle of 28 degrees. So C, opposite angle C, as you can just see here, that here's C, and this line is opposite it. It looks at it. So that's and it's next to the angle, so that's why it's called little c. And it's one of the arms of the angle that we know, one of the arms, so the hypotenuse. So it's the adjacent. It's adjacent. Cool. And then this one, here's our angle. It's opposite the angle, and it's opposite A as well. So A happens to be the angle in this case. So they, opposites collide. So there we go. So that's got everything all labelled up. And just to be clear, we want to find the opposite. So let's get into our maths toolkit and take out our SOHCAHTOA. Here it is. So what do we know? Well, we can find the sine of 28, the cosine of 28, the tan of 28. So we know SC and T. We know the adjacent. We don't know the hypotenuse. And we don't know the opposite, because that's what we want to find. So we can see there that definitely we won't be using sine, because we know bugger all about that. Cosine we've got 2, but the opposite's not in that ratio, so that's no good. We could find the hypotenuse, and then we could maybe use sine, but that's sort of using one to feed off the other. Far and away the best one to use is the tan. We've got the tangent ratio, and we know the adjacent, use the opposite. So yep, well, that's the one I choose. All right, so we know that tan 28 degrees equals the opposite over the adjacent. The adjacent is 107.8. So the opposite, if you imagine tan 28 over 1 times the opposite equals tan 28 times 107.8. Alrighty, and apparently it equals 57.32, but let's get the calculator out and confirm it. Oh, it's already typed in there, but so we'll just make sure. Make sure you've got it in degrees mode, always. Tan, oops, no, we've got to push the button. Tan 28, close the bracket, times 107.8. 107.8. I'm using the keyboard on my 107.8 equals 57.318276673. 57.32. I've sort of rounded to 2 decimal places, so I think that would be enough in this case. So in some cases, maths determines how many decimal places you have. In other cases, practicality. So I don't think you'd want it any more accurate than that. I don't think to the millimetre would be pushing it a bit. So there we go. And just to make it easy for our tutor who maybe has to mark this, let's just write it out there, plain and simple to see. Bob needs 57.32 metres of line. Bloody marvellous.